Hello and welcome to Morehouse's Math Menagerie. Today we're going to be talking about Stemplots. But before we begin, I thought we would take a moment to appreciate this inspirational quote by Chewbacca. Alright, enough of that. On to Stemplots. Alright, here we are given a sample of 30 Army soldiers' head circumferences in centimeters. This is the type of data that we'd be gathering in order to provide helmets or other gear for soldiers. You will notice that the data goes from about 20.8, is that the smallest value? I think 20-ish is the smallest value, and then the largest value goes to 24.9, I believe. So we have a range in our data from 20.8 to 24.9. Now we're going to use that information to create stems. So for this problem, our stems are going to be our whole numbers. So we start with the smallest, 20, and then order all the way up to 24. We want to make sure that we include all the numbers in between 20 and 24 if possible. If the range was something ridiculous like 20 to 240, then we might have to figure out a different scale. But usually for Stemplots, we're going to go just in numerical order for all the numbers between the smallest and largest stem. Now, looking at our first number, 23.0. The 23 is going to serve as the stem, and the 0 is going to be what we call the leaf. So we're going to take a 0 and put it over here on the 23 row. So this would be interpreted as 23.0. Now you'll notice that I went ahead and struck through this value just to make sure we know we already used it and don't double count it. The next value, 22.6, so the stem is going to be 22, and then the leaf is going to be a 6. So we're going to add the 6 onto the 22, and then we'll just keep going from there. An 8 would go onto the 20 row. 4 would go onto the 23 row for that stem. 22.7, the 7 would go onto the 2 row. 21.9, we would add a 9 onto the 22 row. Now you'll notice this next value here is 22.2. Now we already have a 6 and a 7 on the 22 stem, so we're going to bump those over in order to keep the values in numerical order. We want to go from smallest being closest to the stems to largest being further away. Now, if I continue this process, I end up filling up my entire stem and leaf plot. You will notice that I added a key down here at the bottom that allows people who are reading this, even if they don't know the context of the problem itself, they know that this stands for a 20.8. And the stem plot allows us to get a quick glance at this symmetric distribution shape here. It doesn't give us a lot of other information about the distribution without us digging in a little bit more, but it does allow us to have a quick glance at the shape of the distribution. Now, let's look at a second problem. So here we are given the college graduation rates for all 50 states. College graduation rates are calculated by taking the percentage of students who graduate with a bachelor's degree within 6 years of starting the degree. So bachelor's, it should take 4 years, but they give you 6 years to be included in this statistic. Looking over this data, you'll notice it's all whole numbers, number one. Number two, it ranges from somewhere in the 30s, I think 32 might be the smallest, up to, it looks like 71 is our largest. So we're going to use the tens place as our stems. So we'll have 3, 4, 5, 6, and 7 as our stems. Now, if we went through that list of 50 states and added on the leaves, we would get something like this. Now, again, I've added a key at the bottom, so whoever was reading this would know that 3 line 2 stands for 32, not 3.2 or something like that. Now, one issue we have is this graph looks fairly symmetric, but there's a ton of data here in the middle, and it's kind of hard to tell the overall shape of the distribution. It's almost like we're zoomed out too far. So to zoom in a little closer on the data, we're going to take each stem and split it into 2 separate stems. So there'll be 2 3s, 2 4s, 2 5s, and so forth. The leaves are then distributed using the normal rounding rules. So 0 through 4 would go on the first 3, and then any 5 through 9 would go on the second. And again, for the 4 here, you can see we get 0 through 4 goes on the first stem, and then 5 through 9s, any values in there would go on the second stem, and so forth throughout the entire stem plot. Now, by breaking it up like this, you can see we're getting a little bit of a left skew. We have kind of a bulge here, and then it kind of flattens out here on the left-hand side. So this gives us a better understanding of the actual shape of the distribution. Now let's say we want to look at this data in a different way. We want to compare states that are west of the Mississippi to states that are east of the Mississippi. And we want to look at how their graduation rates are different. We could create what is called a back-to-back stem plot. You will notice here we have the same stems in the middle of the plot, but the leaves for states west of the Mississippi go to the left of it, and states that are east of the Mississippi go to the right. Now, you'll notice again here these leaves are going smaller to larger as they go away from the stem on the left and on the right. This is a little bit unintuitive on the left because we're used to reading from left to right, but here we have to do it from right to left. Now, this allows us to compare the distribution of graduation rates from cities or states from the west of the Mississippi and states that are on the east of the Mississippi. You will notice first off that on the west we have a few lowballers over here who are not performing very well. But in general, this is a fairly symmetric distribution. On the east, they tend to have higher graduation rates, and this distribution here is pretty skewed to the left. We have quite the tail going here to the left, so we would say skewed left for this. All right, well that's it for today. This awesome image of a guy getting crowned popped up when I Googled stem plot cartoons, so I thought I'd share it with you today. Hope you have a good one.